Perfect. Well, thank you, Dr. Earl, and for everyone for joining this morning. My name is Peter Crank. I'm an assistant professor at the University of Waterloo in Canada, and I'll be talking a little bit about some research that I have done with colleagues at Arizona State and INCAR in the U.S., where we looked at the socio-demographic determinants of extreme heat among older adults within 3 sunbelt cities. So I'll sort of walk through what some of those things are. So some of the motivating factors for why we wanted to study this. First of all, urban populations are growing here in Australia, in the US, and around the world. In the US specifically, we're already over 80% of an urban population, and that's actually continuing to increase. And by 2035, we expect to see that urban population will be 20% older adults. So 1/5 of the urban population being above the age of 65. In addition to that, much of the exposure for people in general, but particularly for older adults, is going to be indoors. Broadly speaking, people spend 90% of their time indoors, and that number is oftentimes higher for older adults. And we do also know that building characteristics played a very significant role in the 2003 heat wave across France and Western Europe. So we became very interested in how are these building characteristics relating to the older adult population. And then lastly, as we continue to see year after year, cities and the rest of the world are continuing to warm. Estimates from 2012 were that US cities were warming at about 1/4 degree Celsius per decade. So we should be 1/4 degree warmer now in the US compared to when this study was completed. But for cities specifically as well, urban-induced warming is likely about the same magnitude as our global greenhouse gas emission forcing. So we're warming our cities at the same rate as the rest of the world is warming, so we're sort of doubling on top of that. So that becomes a highly important issue for us in the cities with older adults. Additionally, air pollution is another component of what this study is going to be looking at. And air pollution and heat waves oftentimes are coincident. Research has shown that the global annual deaths for this are around 7 million for just air pollution. But when you combine the two together, we're almost doubling again that risk. And elderly are among the highest at-risk groups for both air pollution and extreme heat. So we're very interested in that. And then last motivating factor, heat wave combined with power outages, sometimes called cascading or compound hazards and events, are an increasing concern. This is from 2003. We've had multiple issues like this since then. But in 2003, we had the Northeast blackout that covered much of the Northeast US and major population centers in Canada, where power went out in the middle of the summer in extreme heat. You have the India blackout of 2012 that impacted nearly between 300 and 600 million people. You have the Texas power outages, first in the winter and then in the summer months. And so all of these are becoming more and more common and increasingly of concern to residents as well as to policymakers and obviously us as researchers. And then there's the future risks. As heat continues to increase, infrastructure ages, there's the increasing threat of cybersecurity. The combination of extreme heat and power outage are very prescient to many people. So why are we looking specifically at older adults and specifically in sunbelt cities? So as the U.S. population ages, we're looking at 3 cities that have high and even growing proportions of older adults. Each of these cities has over 10% of their population are over the age of 65. These are also really common locations in the U.S. for older adults to retire to. They work in northern climates in the U.S., and then they finally have enough retirements, so they move further south. So then they're being exposed to hotter conditions than what they're used to as they continue to grow older. So these are also cities that are known for their ozone and air quality issues. So we're combining that extreme heat with the air quality issues where we have increasing numbers of older adults. So we're trying to better understand how would we intervene to prevent some of these issues from occurring. So our 3 main objectives with this research study was to use a semi-structured survey of older adults in these 3 cities to explore to what extent do building characteristics influence self-reported heat or ozone-related health outcomes among older adults. How do demographics and underlying health conditions impact these outcomes? And then what are some of the modifiable behaviors or conditions associated with these negative heat or ozone health outcomes? Things like indicators of resilience or adaptive capacity. So a little bit about our methods for this study. So we used telephone surveys of older adults in 2017, aged 65 and above, living in Houston, Texas, Phoenix, Arizona, and Los Angeles, California. This was conducted, the survey itself was conducted by the Portland State University Survey Research Lab. And we asked questions that were focused on respondents' experiences of the summer of 2017. We conducted this from the 3rd of August to mid-September in August so that we had, the memory hasn't been lost from that previous summer. They're still dealing with some of those effects, and so it's much more easy to recall. This table here just sort of shows the overall statistics for it. We had a sampling error of between 5.6 and 5.65. We collected over 300 respondents in each of the 3 cities for a total of 909. Most of them were in English, and then a couple were in Spanish as well. So to look at what we are dealing with in these cities, we use a mixed effect logistic regression model where we used odds ratios, which basically tell us if it's on the 1 line, there's no difference. If it's below 1, we're seeing somewhat of a protective or reduced in risk. If it's above 1, we're seeing a greater risk. And the way we developed our models were to have a heat health and a ozone health outcome one. So our outcome variables are sort of in the orange here. And then we had fixed effects and random effects. Random effects allow for unique intercepts for each subgroup. So the lines are going to be 3 separate lines or 2 separate lines in the instance of ozone health. And so those lines are going to be based off of age, city, and whether or not they own their home or they rent their home, because that can oftentimes be an indicator of both income, but also how much autonomy do these individuals have over their home and over their residence. When we look at the fixed effects, these are going to be effects that are estimated across all the different groups. So we're looking at AC access, respiratory health, weatherizing the home, the color of the roof, and whether or not they open their windows during the summer months. So those are all the different things that we put into the model itself, and then we get an odds ratio outcome estimating for heat health on that one. For ozone, we looked at the city and gender as our random effects, and our fixed effects, again, our AC access, pre-existing respiratory health conditions, pre-existing mobility issues, as well as the amount of time that is spent outside. So those were the 2 models that we use. So first, we'll look at the heat model. So again, these are odds ratio plots. We have fixed effects on the left, random effects on the right, and then the line through the middle is your odds ratio of 1. So that's sort of the neutral position. If it's to the left of that, it's protective, increasing risk to the right. So what we're seeing in the fixed effects section of the heat model is that pre-existing respiratory diseases, whether or not somebody's opening their windows, as well as having central AC but not being able to cool their home effectively. So maybe that's because it's broken, or they don't have the money to pay for the AC costs as it runs through the summer, or if they don't have AC units at all. These are some of the things that are increasing risk. That's why they're highlighted in red. The big one being the fact that they have central AC, but they can't use it very well. They might be trying to rely on it instead of buying window units or portable AC units, but they can't because they cannot afford, or it's broken, and therefore don't use it. On the random effect side, some things that are slightly positive but non-significant in terms of the difference are whether or not they own their home. So renting their home seems to be a very slight increase, but probably not significant. And then age as well. As they get older, it seems like they tend to be less and less likely to have some sort of heat health outcome, but it's not fully statistically significant either. So it is very interesting. We expect that risk to go higher as they get older, but it seems to be going the opposite direction. For the ozone model itself, same plots, just different variables here. Some of the ones that stick out for us in terms of elevating risk are pre-existing respiratory conditions and diseases. Unsurprising, we're talking about ozone. If you're struggling to breathe, ozone is going to be a significant issue for you at the surface. And then we also saw a surprising increase among the female population over male with this one. Some sort of slightly positive but relatively neutral are a lot of these other fixed effects: pre-existing mobility, their AC usage, as well as the amount of time spent outside. These seem to have a slight increase, but not a statistical increase in their risk for ozone-related health outcomes. And then very interestingly, the male group within the survey seemed to have a bit of a protective influence in the random effect. So a little bit of sort of summarizing discussion of what we looked at with this. The city regional impacts we thought would be much stronger. They weren't. Despite the fact that AC usage is very different for Los Angeles compared to Houston and Phoenix, that relationship did not result in any sort of significant increase in risk. However, the fixed effect side of things for heat, the ability to use central AC without limitation is this key factor in determining risk for heat health. Pre-existing respiratory diseases can play a role as well, but the primary one here, again, continues to be that central AC usage. And interestingly, the opening windows doesn't seem to help cool the home, but we are thinking that that's possibly due to the fact that their home already got too hot, so then they opened the window to try and cool it down. They didn't open their windows prior to their home becoming too warm. For the ozone side of things, again, cities didn't play as big of a role as what we thought they would, and gender was a surprising random effect in this that influences some of that baseline risk. On the fixed effect side, pre-existing respiratory disease, unsurprisingly, is that primary role for ozone-related. But your AC access and use, as well as time spent outdoors, are playing roles in this as well. So again, some of the main takeaways, sort of summarizing all of that: central AC, this is the primary thing in the US that is going to help protect against heat health, particularly in these extremely hot cities. But this is good information for public policymakers and emergency responders, because ensuring that central AC access is available to older adults in these cities can be a means by which we are protecting the population during the summer months. Maybe that's suspending the auto shutoff of utilities for people who can't pay during the summer months, and waiting to shut that off until it's cooler might be a way to help prevent some of these impacts. So these are some of the policy and emergency response mechanisms that can be utilized. Some future work that we'd like to see done in this space, including ourselves and others, is to better explore some of the relationships between protective behaviors and the outcomes. We asked them about things like drinking lots of water, taking cold showers, those types of things. But we realized in the model and how we set up the survey that we didn't ask if they did this before or after they experienced extreme heat conditions. And so we didn't know if that protective behavior was a preventative or a diagnostic response to it. So we excluded that from these studies now, but future work, we hope to continue to do that. So with that, I'd just like to acknowledge the Survey Research Lab at Portland State for conducting it, and then acknowledge my co-author, Cassie, who has been doing a lot of the work alongside me, as well as our other co-authors and other people within the larger project. So thank you. I'll take any questions.
Thank you.
Yeah, Richard Didier.